It's basically the same stuff as everything else.
When's the due date for 2/6?
The 25th. So
Okay, so you can just look at the little video and see those last two.
Yeah, so the rest of the stuff is on.
No,
You don't left one, but for this stuff, it's just simply saying substitute.
Yeah, FOG.
Yeah. So just put numbers where the X's are and you call it a day. Math.
Math stuff.
Yeah, basically. I never really do this type of stuff. This is the stuff that I understood like 3 years ago when I learned the numbers stuff. Yeah, I spent like probably on the first half of the homework this morning, just because of stuff that they want me to do.
Kevin, very, very lovely.
They would take it.
Okay, I'll pass the attendance sheet around also. I don't know if we signed in last time, but
No, we didn't.
okay, so sign in for last time and this time. Okay, everybody listen what I'm going to tell you right now. First of all, I don't know if you saw the announcement that I sent out, but when I leave you high and dry with a few problems, because, I mean, there's only an hour and 15 minutes. That's all I really have for each section. So when that happens, and I didn't do like maybe the last 3 or 4, I'll post like a little extra video for you. And it'll, you know where it says Echo Video Recordings? Right there in Blackboard? Right underneath it is where I'll put the extra videos, because I can't add it to the general collection, because that's programmed by the virtual campus. I don't know how to get it there. Right where you see Echo Video Lectures, right on Blackboard, there's one of those buttons coming down the side. Right underneath it, you'll see Section 2.6, numbers 13 through 16. So if you have to look at those, but basically it's this. You tell me you didn't understand the fog problems, FOG. They're really just substitution. Those are actually the easiest ones on the section because the other ones are hideous. By the time you left the other day, you were crying.
Yes.
But what can I do? When you go into my math lab, they actually do get that hard. So I was obligated to include in my lecture the very hardest ones that I found in my math lab. But the ones that you're saying you don't understand, they are going to be on the class activity, by the way. We're going to do another class activity today. They're easy. Like if I give you something like this, like that's one function, because this whole section is about putting functions together in some form or fashion. It's about composite functions, where you combine functions, either through, remember when we met the other day, we were adding functions to put two functions together, or we would subtract and put two functions together, or we would multiply or we would divide, but we were putting them together. And then we would figure out the brand new domain, and they got pretty hairy at the end there. They were very complicated. But these are easy. Because if, especially if I give you first degree equations, I'll give you 2 equations, but this time I will tell you to put them together through the composition function. So if I tell you do this, looks like the word fog, the big circle. If I say do this, that literally means I could say it a bunch of different ways. You are plugging this into this. Well, you can't plug anything into something else unless you open up a spot in the first function to plug it in. So when you read this out loud, it can be read F composed of G. That is one way to read it out loud. You want to break it down to street language? It's G substituted into F. So easiest way, one second, the easiest way to do these is just open up the front function. Always open up the front function. Now when I say open it up, I mean go to the F function right here, copy it, we'll put a blank spot or a parenthesis right where the X is. That's what I mean by open it up. You're opening up a receiving area so that you can dump the G function into the F function. So it's pretty simple. Open up this F function, leaving a parenthesis where the X is. Now that you've opened it up, you now have an open spot to go and plug the G function into the F function. So you're just substituting one into the other. Okay, you're going to substitute, not that part, that's just the name of the function, this part. Put it right in here. Go like that. 6x minus 15 plus 9. Clean it up. It will be 6x minus 6. That's it. Okay, if somebody tells you to do this, how about if they go like this? Do f of g, and then they have like a little number hanging off the back. That also means substitution. Because you already did this part, right? So if you're going to take what you just got, 6x minus 6, and you're going to do this to it, that means take your FOG answer and evaluate it at -2. So now you would go 6x minus 6, and you go and dump that number in so that now you're getting a numeric answer. -12 minus 6, -18. If on the other hand, instead of FOG, they say do GOF, switch it around. All you would do in that case would be, now before I do GOF, now what's your question?
I was trying to just look at the video you posted on Blackboard, but it just has an error for the lessons that you did. If you want to look at it, it just says error.
Yeah, I don't know why. I have no idea why. Because I watched them last night.
Yeah, I tried to look at it on my phone and it said error. So I wanted to see if it was just because of the phone, but no, it's not even working on my laptop. So
Like last night I actually played them.
no idea.
I mean this morning I actually played them.
Unless
So
it's just my laptop maybe?
I don't know. But anyway, I think the only thing that probably you might be questioning is this, but I actually sat there for half an hour and made a video for you, an extra video for you. Why you can't see it, I don't know. And I won't have time to make another one now, because now I have meetings scheduled from here all the way till whatever, so you're going to have to take what you can get from this. Okay, so the G of F, just same thing. And I don't know, you don't really need to be shown every problem. To tell you the truth, that's not what those outlines are for. It's to give you the general idea. So, did I not go from the simplest problems to almost the level of disgusting how hard they were? You guys were disgusted, right? Okay, so I think I hit the bases. I'm pretty sure I hit the bases. You do have enough. The only ones you didn't have examples for were these, and I'm now giving them to you. So hopefully the video, maybe it was your computer. I could have sworn I opened it up this morning just to see if it was, if it had gone live yet, because I did it yesterday, and then they were processing it all night last night. So I don't know why. But anyway, G of F. So just remember it this way. If you're going to substitute, this means you're substituting the back one into the front one. So always open up the front one. Make it like an open receiving area. So go grab 2x minus 5. And go dump in the F function, which is 3x plus 9. The only way that these can get harder is if I give you harder expressions. Like if I start moving you to second degree stuff instead of first degree, then of course it's going to get harder because you have to be better at the algebra. So if I give you something like this, okay, say I give you something like this, and I ask you to do F composed of G, evaluated at 2. Just do this first, F composed of G, and what I just said, this will be my third time saying the same thing. Open the front one. Open up the front function so that you can then plug it into the open, that back one into the open one. Okay, so the front function is x squared plus 3. That's what it means to open up something. Put a parenthesis where the x is. Okay, now go dump the G function into the open spot. Now, of course, you got to be better at algebra to do this because it's no longer first degree. You're going to have to know how to do that magic thing called foiling. Okay, so some of you are still foiling like this. I wish you'd stop. There are shortcuts for certain things. I mean, sometimes you have to foil the long way with the 2 arrows and the 2 arrows on the bottom and collect my term. You have to do 5 steps. That is not necessary here. There's certain things that I tried to teach you shortcuts for. This was one of them. Squaring a binomial, the shortcut is square, double, square. And when you get how easy that is, you'll stop even writing square, double, square. You'll just be reciting it in your head as you do it. Then you won't have to write 2x minus 3 and 2x minus 3 and draw 4 arrows and follow the 4 arrows and combine like terms. You could just be looking right at this while you do it. Square means square the front term. Well, the front term's got a number and a letter. You have to square both. So that would be 4x squared. Double, that means multiply these two things. Negative 3 times 2x would be negative 6x, right? But then you double the coefficient. So 6 times 2, 12. And then when it says square again, but this time the back term. So the front and the back are positive, because they come from squaring. You can't square and get a negative. And then this comes from multiplying. You can do that in your head. 3 times 2, 6x, or negative 3 times 2, negative 6x. And then you just double the number that was there. And you really cut through a lot of work. Not that you're done, but anyway, you have to know how to FOIL, and I'm hoping that you will adopt the shortcuts as they are offered to you. I'm not the first teacher that I could show you right in the MAC1105 book where they appear many, many times. All right, so anyway, clean it up if you can. If there's terms you can put together, there's 2 of them. It'll be 4x squared minus 12x plus 12. So that would be f composed of g. And then what did I say, plug in a 2? See, sometimes it says plug in a number, and other times they just want this. Okay, if they leave an x here, that means, okay, that's good enough. If they put a number there, that means go on to plug in the number. Minus 12x plus 12. Anyway, this is 4 times 4, 16. Use your calculator if you want to. That's 18, take away 24, negative 6. Okay, anyway, I'm digging into my time for section 2.7. We're supposed to be doing 2.7 today. That was just, so did you try to get into the video?
I tried with this error that you don't have access to it. And then if I try to go back to the home page, it's like you're not even logged in as a student.
You're not logged in as a student?
Well, it'll be like, oh, you're like logged out or something, log back in.
Okay, well, I'll look at it later. Right now,
No rush.
yeah.
Let's do the one.
I might not look at it at all because I've already given you enough. I've given you too much from 2.6. I mean, at some point, I'm just doing the homework for you. Well, I know you wish I could do that. Let's actually go on to stuff that we haven't learned yet because I want you to get to the point where you can practice on your own. Now, where are the worksheets that I gave out? There's one right there. Okay, I got a clean one right here. Let me get myself organized and ready to roll. Turn on the video. Okay, everybody ready? Here we go. We're going to do 2.7, and then we are going to finish the class with a half an hour, 25 minutes maybe, activity where you're going to review 2.5 through 2.7, okay? When you leave here today, I will post. You better be on top of your game now. We are rolling into the next test. The time is to get ready is not next week. You wait till next week, you're done. Forget it. Okay, I want you to start getting ready today. I'm going to tell you in very small increments what to do today, what to do Friday, what to do Saturday, what to do Sunday, so that you're setting your, I'm teaching you to discipline yourself, to spread it out so that you are not cramming everything in at the last minute and gobbling up the time when you should be doing practice test, practice test, practice test, the one that I made with the video. I'm not saying that you shouldn't also do the review practice problems that are in my math lab, because the people that aced that test and got over 100, they did both. So I'm going to tell you today, you need to go home, and I'll type it out for you, and you'll see it as an announcement, okay? Be looking for that. I'm going to type it right after you leave today. You're welcome. Okay, here we go. Now you are learning about inverses in this section. So, in the simplest sense of what an inverse means, like even when you take like a pre-algebra class, some people take pre-algebra even like when they're in 6th grade, and they try to introduce a lot of the same concepts, but on a more basic level. So on the most basic level, before you actually know how to graph too well, and you don't know how to analyze graphs yet like you do now, you're learning that now because this is a graphing class, they teach you that inverses are when you take the points off of a graph and you switch the x and the y. So the most basic way to describe what an inverse is for me to tell you that, and you're going to see that that concept, me switching the x and the y, is going to resurface over and over again in today's lecture, but on a more elevated level. Instead of saying switch the x and the y, which I will do in some of the procedures I do, what do we call the x's now? Domain? And we call the y's the range. So I'll be more sophisticated and I'll say switch the domain and the range for certain reasons. That switching of the x and the y is the basic meaning of inverses. Functions that are inverses. That for every point on the original graph on the inverse, which we'll find, it is y and the x switched. Okay, that's going to keep popping up. Now, I don't think I've left myself much room to do any of the problems here, so therefore, I will move to paper. All right, so I want to explain to you, although I have very nicely typed it out for you up at the top, so you wouldn't have to write it yourself, but feel free to write it twice. I want to describe to you what one-to-one is. I think the best thing in this class is to have a highlighter. Let's pick out from that paragraph, what are the important things? I want you to know what one-to-one is. Because only when a function is one-to-one can you find an inverse. There are no inverses unless it's one-to-one. So let's break it down even more basic. A graph is one-to-one. A function, when it passes the vertical line test, you know how to do vertical line test, right? You just get a picture on your graphing calculator or do it by hand. See if the vertical line passes through it at just one point. It passes the vertical line test, but now it also has to pass the horizontal line test. And if you don't have that going for the graph the function that I started you with, then you better not bother finding the inverse because it doesn't exist. That's what it means to be one-to-one. So the important things here are that it better pass the horizontal line test and it better pass the vertical line test. It needs to pass both the vertical horizontal line test. Those are the only important things in that paragraph and throughout this lecture. All right, so here we go. So it says the function, now they're telling you straight off the bat that the function that they're giving you is one-to-one. And let's imagine it. Do you see that this is all first degree, this whole function over here? What does the picture look like when it's all first degree? It's a line, right? So I don't care whether it goes this way or this way, it doesn't matter. Won't it pass the vertical line test? Won't it pass the horizontal line test? That's why they're telling you it's one-to-one. Now, if they don't tell you that it's one-to-one, you have to figure it out yourself. You have to imagine the picture, and I think some questions are just that. Hey, here's a function, you go graph it, you tell us whether it's one-to-one. If they're telling you it's a one-to-one, you therefore have permission to find the inverse. Okay, when you do find the inverse, what are the steps? Okay, it starts like this. Step 1. Okay, this is finding the inverse. You finding the inverse function. By the end of this lecture, we're going to work up to you finding the inverse, you finding the domain and the range of the inverse, and then getting both graphs on the same grid, the original and the inverse. Okay, so we're going to start with step 1. We're going to take the original function, f of x is equal to 3x plus 1, and we're going to replace the f of x with y, because everybody knows f of x is the same thing as y. So in step 1, we'd be going y is equal to 3x plus 1. Step 2, switch the x and the y. The main basis of finding an inverse. Switch your x and your y. So I'm going to put an x here, and I'm going to put a y over here. Step 3. Okay, now you're going to actually go into the part where you find the inverse. You're going to solve for the brand new y that you just created, which is this guy here. It used to be an x, now it's a y, so I call it the brand new y. Solve for that y. Solve for the new y. And when you solve for that new y, you will have found the inverse. Okay, to solve for y, that means get y by itself. So bring the 1 over here, leaving the 3y on the right-hand side, then dividing that 3 right off of there. Okay, and by the way, once you get the y by itself, you're done finding the inverse. Here's the symbol we use for inverse. Little f with a power. It's not really a power. That's the inverse symbol. It doesn't mean raised to a power of -1 in this particular case. So there's your inverse. And some people like to write it like this. They like to go that the inverse has been given, here it is over here, in terms of x. You'll see that notation written quite a bit. But anyway, I want you to understand that inverses are operations, and this is also part of that paragraph up at the top of the page. They undo each other. Like, for instance, you guys have learned about inverses on a basic level, and then you continue to elevate your knowledge of what inverses are. Like, for instance, when you first learned about, your teacher gave you a little equation, x plus 3 equal to 10. Didn't you try to get the 3 to go to the other side, and you would just subtract 3? The reason you subtracted 3 is because when you started the problem, there was x plus 3 equal to 10, and you wanted to reverse the effect of a positive 3. You wanted to do the inverse of a positive 3 to get it to go away. That's what makes things cancel, or in other words, what undoes something, an inverse. So if you start off with a problem, of course, the markers are over here. I'll just walk back and forth for the rest of the class. Forget about doing any problems. So when you start off with this, maybe you don't know that they're called inverses, but by doing that, you're undoing something that was in the original problem. Those are called inverses. I want you to see that everything that is in this answer right now is the inverse operation, just like -3 is the inverse operation of positive 3. Everything that's in my answer right now is the inverse of what was going on originally in the problem. Let's look at what was going on originally. When we first started this problem, wasn't the x being multiplied by 3? Now it's being divided by 3. Wasn't 1 being added to the x term? Now 1 is being subtracted for the x term. So everything, some people can do inverses in their head because they know that they're just reversing everything that was going on in the original problem. I mean, if it's basic enough. If the problem's too hard, it's hard to do it in your head. But some people can do like these in their head because you're really just reversing all the operations in the original problem. All right, so I think that's all they asked us to do here was just this. So that was number 1. Okay, number 2. Okay, we're getting a little bit creepier here. X to the 3rd minus 5. They're flat out telling you that it's 1 to 1. And when somebody makes this comment right here, that means you have permission to find the inverse because it does exist. But you do not have permission to find it unless either someone tells you it's 1 to 1 or you can figure it out yourself. And again, I'll say it again. A function's 1 to 1 if it passes vertical and horizontal line test. Okay, so let's go to this finding these steps. Okay, all I'm asked for is the inverse. They're not asking me for a graph or domain or range or anything like that. So step 1, replace the f of x with a y. Step 2, switch the x and the y. Step 3, solve for the new y. In other words, isolate this new y. So I'm going to bring the negative 5 over here, leaving the y cubed by itself. And then you really never have solved anything unless you get it to be first degree. So I'm going to make the cube go away. I'm going to go cube root, cube root. And then the cube root of a cube makes that go away, takes the radical with it, out pops the y. So what you see right here, the cube root of x plus 5, that is your inverse. And you can put the inverse symbol there. Okay, all the opposite operations are happening once again. In the original problem, 5 was being subtracted from x, not being added. In the original problem, you were cubing something. Now you're cube rooting. So it's all the opposite inverse operations. Okay, let's go to 3. Stop me if you need more explanation than what I'm giving you. Okay, number 3. You're starting with, so numbers 1, 2, and 3 are just basic, find the inverse. You're starting with f of x is equal to 16th root of x. They tell you that it's 1 to 1. That means you can continue, and you can go ahead and find that inverse. So step 1, replace y with the f of x. Just put y in its place. Okay, step 2, don't forget, switch the x and the y. Okay, then get rid of the radical that's wrapped around the y, because you want the y to be all by itself. So just like you would get rid of a square root by squaring, or a cube root by cubing, you get rid of 16th root by raising to the 16th power. So raise to the 16th power. A power undoes an index. That's called an index. Whatever you do to this side, do it to this side as well. So now this dissolves the index, takes the radical with it, out pops the y. Over here you have x to the 16th. And I would tell you to get the new y by itself, but it's already by itself. So this is your inverse. Okay, so your My Math Lab problems will start with basic problems like that, where you just try to show that you know how to undo certain operations and that you have learned the 3 steps for finding an inverse function. Okay, later they'll get more complicated, so let's move to those problems. Okay, number 4. Okay, 4, I think there's nothing to do for 4 or 5 other than to eyeball the picture. Okay, look at the pictures that you're seeing here. The question is just simply, do these 2 problems have an inverse? Okay, now you're going to have to remember, and depending on how bad your memory is, you better keep just writing the definition. What did I say? What kind of test does the graph have to pass? Okay, and if you can't remember that, then make a little note off to the side. Because when it passes vertical and horizontal, that means it's 1 to 1, and only one, because that's the definition of 1 to 1, that it passes vertical and horizontal line tests. And only those kind of functions have an inverse, which is what you're being asked. Does this have an inverse? Even though you don't have a function to go and find it. So what you want to think is, does it pass the vertical line test? Yes. And you can maybe even show that in your notes. Because these are good, these notes are good to use when you're doing the class activities. You can be looking at these while you do the problems. Does it pass the horizontal line test? It has to pass both of these. What do you think? Does it pass the horizontal line test? No. Passing a test means that that line doesn't cut through the graph more than once, when this one does. So, nope. Therefore, doesn't pass that one. Therefore, this function, this graph right here, does not have an inverse. Does not have an inverse. And that's all they're asking you. Does it have one or does it not have one? You couldn't have found it anyway because you don't have an actual function, just a picture. Okay, do you understand that in the next graph, for the same reason, that bottom graph also doesn't have an inverse? Because it also does not pass the horizontal line test. I mean, you could think of the x-axis as a horizontal line. Look how many times it cuts into the graph. The graph is the wave that you see there, which is going to be the emphasis of the next chapter. You're going to learn how to graph those. But look, it cuts through it once, twice, 3 times. And the more that the wave would go on, the more it would fail the horizontal line test. So this fails the horizontal line test. Therefore, no inverse exists. You can write it like this or this. Okay, moving on to the next one. If I give you something like this, and I say, I'm telling you how to do the problem. I'm telling you to go back to basics for this problem. Remember at the beginning I said, like when you're in a pre-algebra class, they teach you that an inverse is just where you switch the x's and the y's. That's what you could rely on right here. So I put that in that box for you, that you could go in, pick the points that are on the graph. Let's see if we could actually see them because, again, I have included a microscopic picture here. So let's see if we could blow it up a little bit. You could tell me if you disagree with what I'm seeing, but your eyes are better than mine. That to me looks like 2, 3. Tell me if you think differently. Then this one right here looks like -1, 1. And then this one looks like -4, -4? Okay, so if I was going to do the points that represent the inverse graph, just switch them. Switch the x and a y and go plot the points, connect them in that shape with a bend right in the middle, just like this bends in the middle. Okay, so if I do, this would represent the original function. These will represent my switched pairs, the inverse points, so 3, 2 instead of 2, 3. Yeah. Oopsie. That's hard to follow. Okay. And then for -1, 1, just switch them. 1, -1. And then, that'll be the same. And then try to plot them and connect them with a bend in the middle. So let's see. I don't know. Okay, you got all those points? Because I'm going to blow it up again. Okay, that one goes with that. I switched them. That one goes with that. That one goes with that. Okay, and so then when I try to plot them, all right, so it's going to be 3, 2. So tiny. Okay, and then the other one's going to be 1, -1. And the other one's -4, 4, so we're going to go like that, and then like that. That's the other side of the graph. Now I'm going to show you something as I do these graphs. This graph's too tiny for me to wedge it in there. But every time you go to do an original graph and then it's inverse right on the same grid, you'll be able to split it right down the middle if you draw a line right through the origin, a slanted line. And when you open it up, you'll have like matching images. So it is said to reflect across the origin. Well, when I get to a bigger size graph, then I'll demonstrate that. Okay, flip over. Okay, again, same thing. Use the graph to draw the inverse. This is the same thing as problem number 6. Okay, so let's see. The points here appear to be 2, 6, 0, 2, and -6, -1. That would be on the original graph, which I'll always call F, and then the points that would be the inverse are just these with the x and the y switched. So 6 up front, 2 in the back. 2 up front, 0 in the back. And then -1 up front, -6 in the back. Okay, so when you plot those, you would have 2, 0, you would have, what am I doing? It's not 2-0. Go away, dyslexia. Okay, 0-2. So 0-2, that's right. Oh no, I'm plotting the original ones. I was doing the right one. Oh my God. Okay. Shake it loose. Okay, so this is going to be 2. What else do I have to do? 6-2. So 6, 1, 2 right there. And then -1, -6 would be down here. And then try to give it the same like round shape as this one has. Now this one is slightly bigger than the graph I just had a minute ago. So you got one piece that goes like this. So what's going to happen every time you put an original graph and its inverse on the same grid, you're going to be able to split it right down the middle across this line called y equal to x. It's just a line that goes right through the origin, and you should have mirror images on either side. So there's an image, there's its mirror image, and this line that splits it down the middle is called y equal to x. That is true of all inverses. They always look like that. If you draw a line right through the origin, and then you open up the paper, you'll have matching images on either side of the line. And you'll see that even when I graph the more complicated ones. All right, let's go to, we'll do 9. Oh, wait, here's one, 8. Okay, for 8, it just says determine whether it's 1 to 1, but they took the graph away. So you make the graph and then decide whether it's 1 to 1. Remember, when someone is asking this, they're really saying, does it pass the vertical? We have to learn how to interpret things for ourselves. It means, does it pass the vertical line test? It better. And does it pass the horizontal line test as well? That's what it means for somebody to ask you, is it 1 to 1? Because if you can't determine it's 1 to 1 in cases where they don't tell you, because in numbers 1, 2, and 3, they just told you, hey, it's 1 to 1, go jump into finding the inverse. Because that might leave you finding the inverse sometimes when you're really not supposed to be finding it because it doesn't exist. So make sure you can tell this. Okay, so this graph, you can do that in your calculator if you want, but it's so easy, I'm just going to do it by hand. First of all, it's a line because it's first degree. This is the y-intercept, and you always start your graph right there when you're doing it yourself. It's actually probably quicker to do it by hand. And then see the 4? Think of it as a fraction. The top is the rise, the bottom is the run. Here's the graph. Start at 1, 2, 3, 4, 5. Start at -5. You always start at the plane number called the y-intercept. And then build your next point using the slope. Okay, I said my slope was 4/1. 4 is the rise. So rise up 4, 1, 2, 3, 4, hold but don't draw the point yet. Now run one space. And then you connect. Anyway, this is the graph. So the question is this graph, does the graph, does it represent a 1-to-1 function? What do you think, yes or no? Yes, because it passes the vertical line test. Swing. And it passes the horizontal line. So you could just say for your work, it passes both vertical line test and horizontal line test. Therefore, it is 1 to 1. Oops, smaller. There's my little notes right there. It passes both the vertical line test, horizontal line test, therefore it's 1 to 1. Okay, then the problems that are the most involved are 9, 10, and 11. Oh, what?
Find the formula, gives the domain and range, then graph both.
Okay, well, let me see. If so, find a formula for the inverse, give the domain and range, and then graph both. So they don't ask it in parts like these do, but 8 is the same thing as 9, 10, and 11. So let's finish number 8. I got to move on to paper though. Okay, so find a form. Okay, so I'm on to this part now. should have said it in A, B, and C format so it's not so confusing. But I'm doing that part right in the middle there, finding the inverse. Okay, let's go grab the original function. Which was y is equal to 4x minus 5. We've practiced this quite a bit. Switch the x and the y. Solve for the brand new y. Bring that negative 5 over here, leaving the 4y by itself. You're almost isolated on that y, and then divide the 4 right off of there. So it's y is equal to x plus 5 over 4. And that's your inverse. Okay, let's keep reading the sentence because there's stuff buried in the sentence. Give the domain and the range for the inverse. Let me show you how to get these, and you will do the same thing for numbers 9, 10, and 11. Remember I was saying that the whole essence of an inverse is where you switch the x and the y? That's the x's are the domain, and the y's are the range, right? So it's the same thing as saying switch the domain and the range. So let me write that for you because it is how you're going to find the domain and the range for the inverse, which is the next question that we're supposed to be answering. Write this in your notes, that the domain of the original function will be the range of the inverse. What used to be the x's will now be the y's. And the range of because the original function has a domain and a range. And the range of the original function will be the domain of the inverse. So start by listing what you think is the domain and the range of the original. Look at this picture right here, because you could tell. The domain you can just tell by looking at the equation. Do you see that equation right there? Did I not torture you with, hey, what do you need to protect so that you don't blow up the function and make it undefined? Do you know that 4x minus 5 can never be undefined? Who could tell me why? This is from a previous section I taught. Why is there no way to disturb that function?
There's no fraction.
No fraction, and there's no radicals. Remember that whole nightmare where we were talking about, hey, what are the things that could actually end up being undefined? Fractions and radicals. Since that doesn't have a fraction of a radical, you can plug in anything you want. That means x can be anything from what to what? Negative infinity to infinity. And if that be the domain of the original, then that also be the range of the inverse. If that is the domain of the original function, you have also just found, not that you need to write it twice. Okay, now it just so happens that when you're talking about the and you're definitely going to want to follow this procedure when you go to the more complicated pictures. Look at the original function to check out the domain. Just look at the equation. Does it have fractions or radicals? Because if it doesn't, it's all real numbers. If it has fractions or radicals, then we'll talk about that. And when you find the domain, looking at the equation, you'll be finding the range of the inverse. But then I think for when you're looking at the range of the original, look at the graph. Okay, look at this graph that I just drew of the original. There it is right there. I'm going to put my original in pink. And I'm going to put my inverse on here as well. Okay, so there's my original. What do you think the domain is for this? What do the x's talk about here? Oh, I already put F. Can you tell by, oh no, we're just looking at the range, sorry. We already did the domain, right? The domain of the original. Okay, so we're just looking at the range. Look at that picture there. How far up do the y's go and how low do they go? Forever, right? So isn't the range also negative infinity to positive infinity? All lines have a negative infinity to positive infinity on the domain and the range. Okay, you're going to have pictures that don't have that. So coming here to the notes. Now that we have looked at the y values on this nice, beautiful original graph, and let's write in here that the range on the picture also turned out to be negative infinity to positive infinity. And therefore, I have also found the domain of the inverse. So this, you're going to have to memorize. The domain of the original is the range of the inverse. The range of the original is the domain of the inverse. So I believe we just answered the next part of this question. They said, what is the domain and range of the inverse? This is the domain, that's the range. Okay, now it says graph it. I've already graphed one. Let's just toss the graph of the inverse there. So just like I graphed that pink line, I'm going to graph another line. You see that this is first degree, right? Therefore, it also has to be a line. Why don't we just write it so that you recognize the y-intercept and the slope. Okay, let's separate it out. Let's go x over 4. There's your slope, 1 over 4. This guy's the rise. This guy's the run. And then 5/4 will be your y-intercept. So that's just like this is the inverse function. I'm not going to write the y anymore. I'll just write inverse. And we now need a graph for that. So I am going to start the graph at 1 1/4 or 1.25. And then I'm going to rise 1, run 4. Okay, starting at 1.25 on the y-axis. This is a y-intercept if you're graphing by hand. Yeah, you don't need to see. All right, so there's where I graphed the pink one. Now we're going to graph 1 1/4 to start with. That would be just like right there, little hair above the 1. And then what are we doing? We're going up 1 and running 4. Now, do you see how I'm just like a hair above the number 1? So every time you rise 1, you'll be a hair above the next number. You don't need to think, like if you're starting off at 1 1/4, when you rise up 1, you'll be at 2 1/4, because MyMathLab might ask you to feed in particular points. And then run 4. So this, I think this was 1, 2, 3, 4. So right from there, go out to 4 and plot that point. Now connect the 2 points that I just graphed. So I believe this was one of them right here. This is the other one. Let me draw this. I'm going to make the pink one longer so I can show you that line that splits them down the middle. So there's that one. This was my original one. And then the line that, not that you have to draw the line that splits them down the middle, I just want you to know, because sometimes they love to ask this question, especially, they might ask this on MyMathLab. What is the line that splits them down the middle? The one that goes to the origin, it's called y is equal to x. And look, when you draw that line, see how it splits it into 2 matching images? You got a V right here. Part of it's blue, part of it's pink. You got a V that goes up, and you have that same V that points downward. So you have matching images on either side. That's always true for inverses. On either side of this line called y equal to x. This was the original. This was the inverse. Okay, let's go to number 9, where I'm going to be doing all the same stuff as I did in number 8. Only now they numbered it A, B, and C. They're more organized in this problem. Here's number 9. I'll do 9 and 11 because then that's just getting too much. Okay, so let's see. Let's copy the equation. Tell me if you can't see what I'm writing because I don't pay attention to that too much. So x squared minus 12. Look, they made a little restriction here for you. And I want you to think about why they did this restriction. If I was to put that in my calculator, x squared minus 12, get your calculator real quick, just so I think a lot of you know that it's a parabola. Do you know that it starts down at negative 12? I don't know. So I want you to look at this graph. The way it is without the x is less, greater than or equal to 0. I'm going to clear out what's there. I'm going to type in x squared minus 12. Look at what this graph looks like, full blown without restricting it. I'm going to do a standard window. Okay, you can't see the bottom of it. Let me give you some more Y min. I'll go down to about negative 15. Okay, anyway. Why do you think that in the problem that I'm doing, that on the side of the function, x squared minus 12, they came off and said only use the x values that are greater than or equal to 0? No, not because it's radical and dominant. Exactly. The way it is now, it doesn't even have an inverse because it fails the horizontal line test. But if you wipe away one side of it, like if we take, what does it say? Keep all the x's that are greater than or equal to 0? That's all of this. They want you to keep this leg and wipe that guy out. So when you put the graph on your paper, you're going to graph it like that. And when you feed it into my math lab. So okay, so you see it starts down there at negative 12, which this ties into one of the other sections that I taught you. That guy right there is a vertical shifter. It takes the parent graph. All parent graphs start at 0, 0, and then once a shifter gets in there, it either pulls it down or up or slides it, back or forth. This happens to be in a place where it's a vertical shifter. That's another way to know that you're going to start at 12. So the graph that you're going to graph for this original function just starts right here at negative 12. And you can look at your calculator to see where it cuts in on the x-axis. I mean, be specific. So if you look at your calculator, where does that dig in? Right between 3 and 4? Okay, so let's make ours, because you're going to see when I do the inverse, it's going to do just the opposite on the x and the opposite on the y coordinate. So 1, 2, 3, 4, about right there. We're just keeping this side. That way, all these x's that are on this curve right here, they're all associated with x values that are greater than or equal to 0. Right here, x is equal to 0 at that point right there. And then all these are x values that are greater than 0. All right, why don't we talk about the domain before we leave what we're doing right now? Because right now, at the beginning of the problem, once you get the graph of the original, is a good time to talk about domain and range of the original function, because you'll also be finding the domain and the range of the inverse. Okay, so the domain. The domain, you should look at the equation. For the range, you should look at the picture or the graph. Okay, so for the domain, do you see any radicals or fractions there? That means you can plug in anything you want, except, look what they told you over here. You would have been able to put in anything you wanted, only they told you right here, we want you to restrict the x's from 0 to whatever you want. Okay, how do you write that? So they're kind of telling you what the domain is here. You could have put anything in here you wanted, but they told you, hey, keep the domain of f at 0 all the way to infinity. And I told you that the domain of f is equal to the range of the inverse. So what I just found right there, by paying attention to this comment on the domain, is really the range that they're asking you for, but it's also the domain. You're answering 2 questions in one shot. You're finding the domain of the original, but the range of the inverse. Now, while we're on this ticket, let's keep going. Why don't we look at the range of the original? It's best to look at the picture for the range. So the range, what is the lowest y value on this thing? And the highest? Okay, so we just found the range of the original. Goes from negative 12 all the way up to infinity. And in finding the range of the original, we have also found the domain of the inverse. Okay, you should not have the same word, domain and domain, when you're doing these. If you're finding the domain of the original, then you're finding the range of the other one. If you're finding the range of f, then you're finding the domain of the other one. But you are answering two questions. Okay, again, what does that have to do with? The fact that the x's and the y's are switched. What is the x's here are considered the y's here. Domain is x's, range is y's. So they're switching from one to the other between the original and the inverse. So this right here is the answer to part C. That's where they ask you for the domain and the range of the inverse. But anyway, part A says, let's do this. Let me number this the way you're supposed to be giving it. It says in part B that you're going to graph the original and the inverse on the same grid. So I'm going to keep this here so that I can complete it in a minute. It is best that when you're doing those answers right there, that you are only looking at the picture of the original. If you put both of them on right now and then try to answer that, you're going to get really confused because it's confusing enough just by looking at one picture. Just look at the original. Answer what the domain and range is, and then that domain becomes the range of the inverse, which we have not found, nor have we drawn yet. Now I think you should do that. Do it in this order, and it will cause the least confusion. Let's go back to A now. Okay, here we go. We're going to find the inverse now that it's not going to confuse us answering this. So the inverse, remember there are steps for finding it. Write the original function with a y where the f of x used to be. Switch the x and the y. And then solve for the new y. Bring this over here. That's equal to y squared. Take the square root. Take the square root. Y is equal to x plus 12. Okay, that's your inverse. Okay, now what else do we have to do? So we did part A. The graph, we're almost done. We have the original on there, and we are now going to put the inverse on there. Use interval notation to find the domain and range of f and of the inverse. We already answered that. The reason I told you to do it right away is because, in my opinion, and you're going to find this true if you try to do it some way different than what I just showed you, the best way to keep yourself as confused, with as little confusion as possible is to just put the original, state the domain and range, and know that this domain is the range and this range is the domain. All right, now I'm going to complete the picture. I've already found all the domain and range stuff. You can write it down here if you want. Again, but domain of f was 0 to infinity. And that's also the range of the inverse. That's two answers in one. And even though they don't ask you until part C, I think you should do it at the beginning. This was negative 12 to infinity, which is the domain of the inverse. Okay, let's finish the picture. Now, I think for this one, because I don't think you're that familiar with radicals, but the radical gives you like a sideways parabola. If you graph both the positive and negative version, you just have a positive version. So you're going to see it's just a piece above the x-axis that looks like half of a sideways parabola. But if you don't want to put all that in your head, just go in your calculator, type it in to get the shape. Okay, type in y is equal to square root of x plus 2, because probably in the middle of a test you are going to forget things like that. Go to where you had the y is equal to, clear out what was there, type in second square root. Underneath the square root was an x plus 12, and you're going to see it's half of a sideways parabola beginning at negative 12. Okay, you can't see where the stem starts, so give yourself some more x-min. Window. X-min, why don't we back it up to negative 15 so we can see where the root of the graph is. There. All right. Let's see if you can. First thing that I graphed, didn't it kind of look like the went up, right, instead of sideways. And that original graph, didn't it start at negative 12? But down on the y-axis, the behavior of the x's and the y's switch when you're doing the inverse of the original. So if the original started at negative 12 on the y, the inverse is going to start at negative 12 on the x. And it's going to have the same shape. But you're looking at the shape right there. Just go copy that shape right onto the graph that I already started at the beginning of the problem. Because they want both of them on the same grid. Okay, so coming back to this nice graph where I had already done the original. I'll put that in this color. And now go to negative 12. Numbers, it's nice when you have graph paper, but go to negative 12, and now we're going to do a sideways one, just like we saw on the calculator. And then if you want to draw that line that goes right through y equal to x, you'll see that these shapes mimic each other on either side. You have this pink one on one side of this yellow line and a blue one on the other side. So like if you were to crease the paper right there on the yellow, you would have this image on the left as well as that same image on the other side. Those are like mirror images.
What it's saying that x has to be greater than or equal to 0, is that only requires the first function, or is that
Yes, first function.
Okay, thank you.
It can't possibly be for the other function because the behavior switched. What you're looking for x is really the y's on the other one. Yeah, the y's on the other one have to be greater than or equal to 12. But anyway, you have all that right here. You're already saying exactly what the x's and the y's can be for both the original and the inverse. Okay, 10 is the same thing. Why don't we skip to one more complicated, but asking the same exact questions as 8 and 9. And I'll just finish this section because you guys, because I did that for you, don't have time for the activity. We'll probably do it next time I see you. So bring your phones or whatever, your phones or your laptops. Okay, so let's do 11, and then I'll do number 12, which is super quick. This one is everything from start to finish. Okay, so 11 you're starting with f of x is equal to x plus 2 cubed. Okay, so I think regardless of the order in which they ask these questions, I think you should graph the original first. You'll be much more able. Now, do you see how that last problem I started with had like a little comment off to the side? X is greater than or equal to 0. And so you have to make your domain 0 to infinity. This one has no comment. So you know what that means? That x can be whatever you want. And this is a problem where no matter what you plug in, you're not going to make it undefined. So right away, remember I'm telling you that when you do domain, it's just a matter of looking at the equation. And unless they have some line, you do the domain yourself. This doesn't have a fraction. It doesn't have a radical. So the domain of f of this original function is negative infinity to infinity. But when you find the domain of the original, you're also finding the range of the inverse, which we have not yet found, but it's good to know that you have found it already. What is the x's on the domain of the original are the y's, or what the y's are allowed to be on the inverse. Okay, keep going with that. You might as well finish it. What is the range? I told you that when you're looking for the range of the original, it is best to look at the picture. Okay, let's go get a picture. You got a graphing calculator. You can go put that in your graphing calculator. So let's move over to that. Graph is best for looking at the range. Go to y is equal to. Feed in x plus 2 cubed. So parentheses, x plus 2 raised up to power of 3, graph it, and there's that answer. You can put less numbers on if you want. Just give it a standard window and there won't be so many numbers. So zoom. That'll clear it up a little bit, but basically it's this. Again, from another section, there was a section where I taught you how do you tell whether it's a vertical shift or a horizontal shift. It's where they put the number. When the number is with the X, like you could see that, you see how this graph doesn't go through 0, 0? If it was a parent graph with no shifting going on, it would go through 0, 0. But do you see that it has moved 2 units to the left as though it was like a -2? Well, look at the original problem that we just graphed. We just learned a couple of sections ago. I know I keep dragging in all the other sections, but we are getting ready for a test. Remember we were learning about horizontal shifting and that when there is a number with the X, you have to switch the sign? So that +2 really behaves like a -2. Do you get why the graph shifted to -2? It's a horizontal shift. That's why. So anyway, the graph, you could just copy it right onto your, onto your graphing paper. So I'll go like this, get my graph started. I do know that it goes right through -2. It goes up like this, down like that. All right, then let's continue. We were talking about that I wanted to tell what the range of the original is. Well, this is the original. What do you think about the Y's on this picture? How high and how low do they go? They go to infinity and negative, right? Range. So says the picture. That picture shows Y values that go to positive infinity, Y values that go to negative infinity. It is too hard to tell what the range is without doing the picture. So get used to it. Use a picture when you're concerned with the range. Range is negative infinity in this case to positive infinity. There was no restrictions mentioned here. So what I just found, when I found the range of the original, I also found the domain of the inverse. Okay, so that's all stuff that you're going to be using in part C, right here. They say to mention all of this, domain and range of the original, domain and range of the inverse. Okay, let's continue. How about finding, actually, let's see, what is this, B, when you're doing the graph? A is when you're actually doing the inverse. So this is part B where you're doing the graph. And when you're doing part A, you're doing the inverse. So I'm just doing what's going to make it easy. Okay, so inverse. Now let's find the inverse and dump the inverse onto this graph. If I would have dumped it on there too soon, it would have complicated me finding all of this. Okay, so here's the inverse. It's Y is equal to X plus 2 cubed. Switch the X and the Y. And solve for the new Y. Do you know how to make a cube go away? Cube root. So cube root here, therefore cube root here. This cube root dissolves the cube, out pops the Y plus 2. And then over here you have cube root of X. Then your Y is almost isolated. Bring the -2 over here. Okay, so I did part A. I'm almost done with part B, and I've already done part C. Part C is this up here, where you find the domain and range of the original, domain and range of the inverse. Let's add to this picture now. Okay, want to know what the shape is? We're supposed to be dumping the F inverse picture right onto that same grid. I'm going to get my calculator to help me out with the shape of the picture that I'm now going to add to the graph. So let's feed into the calculator. Cube root of X. Let me remind you where to grab that symbol.
You didn't write the -2 with the cube root of X.
Oh. There. Now I put it in. That would have been tragic. Okay, so Y. Let's go to Y and clear it out. Clear out what's there. Cube root is under the math key. So right here in the first column, hit math, and go grab cube root, which is option number 4. Dump an x in there, close it, then subtract the 2. Because otherwise it's going to think that the negative 2 is underneath the radical. So minus 2, enter. You can use a standard window to see if it looks any good, and if not, we can adjust it. Graph. Okay, so what you're seeing here is, you know the shape that I just graphed by hand? Or no, I use a calculator, where it went like this. It started like up in the air and went down. Now it's like one of those, but sideways. So just literally copy that picture. And do you remember that wave that I did draw already, how it was shifted over here to negative 2 on the x-axis? Now it's shifted down to negative 2 on the y-axis. Okay, so 1, 2, go like that. You have a piece that goes up. I'll go back to my graph. Adding to the graph now, there was a piece that went like this underneath. And then there was a, just like the way it turns. This one turns, instead of going up, now it goes down. And you can make this longer just so you can see the split. Okay, this was the original. This was my inverse. And here's the line that splits it down the middle. Okay, you got matching images on either side. Okay, last problem. Doesn't have much work. And I already showed you how to tackle it. So I don't have to say too much about it. Can I get rid of this? And you know that you're just going to copy this for part C, right? You already have the answers. Okay, all this one says is use a graphing utility to get the shape. And then it says determine whether the function has an inverse. In other words, is it 1 to 1? That's what you're asking. Does it have an inverse? Is it 1 to 1? You're answering the same question there. So putting that into the calculator to determine really, does it pass the vertical and the horizontal line test? Here it is. Going to y is equal to and clearing out what I have and grabbing the absolute value symbol. Go to math. Over to number operations and grab ABS for absolute value. Dump inside the absolute value what they have, which is x minus 1. Graph it. What do you think? Does that have an inverse? It doesn't pass a horizontal line test. Okay, that's it. Pleasure working with you. Have a good weekend. Look out for my announcement because I'm going to be sending you a schedule of what to do today, tomorrow, and the rest of the days leading up to the test. Hey, for right now, can you guys just, if you want to do, I want you to do the practice test at least one time before I see you. Can you just print off your own, and then when I see you again on Tuesday, I'll give you some copies that I had run off for you. I just don't have them yet. So I'll bring them next time I see you.
What did you do for that?
I went into, to feed it into for y is equal to, you just go math key. And then over to number